Hello and welcome to STEM Decoded. This is the part 4 of functions and its transformation. In this video, we will cover stretches and shrinks that happen when we multiply or divide something to the output of the function or the input of the function. In the last 3 parts, we learned about reflections, shifts, vertical as well as horizontal. So now without any further ado, let's begin with the video. So we will take a look at the function fx equals x squared, and we will see what happens when we multiply and divide the input as well as output of this function. Okay, so now let's try to plot our function x squared here. So we see that we get a curve here, right? Now let's try to multiply something to the output of the function, which is complete x squared. So we multiply something to the complete x squared. And let's multiply 2 to x squared, right? And we see that when we multiply something to the output of the function basically shrinks inside. And we can see that the movement is towards inside, and the function has shrunk as compared to the original function, right? And this has happened when we are multiplying with a greater number than 1 to the output of the function. Output is fx basically, right? And now let's try to add another function here, and let's try to multiply something to the input of the function. So let's multiply 2 to the input of the function. So now our x basically equals to 2x, and therefore we have 2x whole squared, which basically equals to 4x squared. And we see that here on the graph, the function has shrunk more. So multiplying the input of the function with a greater number than 1 also gives us a shrink inside the function. Now let's try to plot another function here, which is dividing the function by a number or multiplying the function with a number that is less than 1. So let's take a number that is less than 1, or let's divide the complete function by 3. So we see that here we have got a stretch. We have got a stretch from the function, and the function has now stretched outwards. When we multiply a number to the output of the function that is less than 1, then the function basically stretches, right? It stretches. Here it shrinks, and here as well it shrinks. Okay. Now let's plot a function where we are dividing the input of the function. And let's notice what happens then. So the input is x. We are changing input to 1 over 3x. So 1 over 3x. And then we can take the complete square of this function. And we see that the stretch is now way greater compared to dividing the output of the function here, right? So we see that when we multiply with a number less than 1 to the input of the function, there is again a stretch. Okay, so what do we understand by this? So when we multiply with the output of the function, multiply with the output of the function by a number that is greater than 1, then our function shrinks. And when we multiply with the input of the function, which is actually x, by a greater number greater than 1, then it also shrinks. And if we compare relatively, we saw that the shrink of the output was less than the shrink of the input, or the shrink of the input was greater than the shrink of the output. Now let's see that when we multiply output, which is fx, with a number that is less than 1, we can also say that we are dividing the output by a number, then the stretch happens. And same goes for multiplying with a smaller number than 1 to the input of the function, right? It also stretches. But the stretch of the input is definitely greater than the stretch of the output. And this does make sense because when we multiply the complete function by a number, it basically increases the output of the function. It basically increases the complete function, right? And what happens is that we see here that this is the original function, and it reaches 1 on the y-axis at x is equals to 1, right? Here we can see. And however, when we see at 2x squared, we are reaching 1 at a sooner value on the x-axis, right? And same goes for 2x squared. However, as this is 4x squared, it's a greater number, and so we will reach y much sooner than as compared to the other function, the multiplying the whole output by a number, right? So now we see that we are reaching 1 on this function much sooner on the x-axis as compared to the other two functions here. So the rate of change basically has increased. Here the rate of change has basically increased, and here as well the rate of change has increased. But the rate of change of this is greater as compared to this. Why? Because this is 4x squared, and the complete function fx has increased 4 times as compared to this one is 2x squared, and the output is increased 2 times. And same, let's look at this when we are dividing the function by 3. What is happening is the purple one is dividing the function by 3, right? So we are reaching 1 on the y-axis at a very later time as compared to the original function, which is in red here. So at a very later time on the x-axis, we are reaching the value of 1 on the y-axis. The rate of change here basically decreases. And let's look at this one. Now, this function is basically equal to 1 over 9x squared. And the whole function, the output is divided by 9, which is a greater number as compared to 3, right? And so the rate of function would decrease more. And we can see it on the graph here that we are reaching the y value as compared to the original function much later on the x-axis. Like it's much later as compared to the original function, which is the red line here. So the rate of change has again decreased and at a greater value as compared to the rate of change here. So we understood that when we are multiplying with a greater number to the output of the function, rate of change or the growth of the function increases, right? It shoots up, it increases. And when we are dividing a function to the output of the function, it's basically very simple to understand and it's common sense. The rate of change or the growth of the function decreases because we are dividing the output. However, it does not make sense generally that the rate of change should increase with the change of. So in this case, it does make sense that rate of change increases and it also increases the output of the function when we multiply something to the input. Now, what happens to a function like this, fx equals 1 over x? Now, do you think that multiplying something to the input of the function will also increase the growth of the function? Not really, because when we are multiplying something to the input of the function, for example, if we are multiplying 3, it's basically getting divided to the whole of the function, and the function basically tends to decrease. and decreasing means stretch. This thing is not constant and it depends on the input, so it shrinks when it's directly proportional to the output. And this also happens when it's directly proportional to the output. So now let's look at the conclusion of this whole exercise and this whole video. So we see that when the rate of change increases, the function tends to shrink. So when rate of change increases, then reaching to the next value of y becomes faster. So here where the function was reaching to the value of y at a very late point on the x, here the function reaches quickly to the value of y, which is 1 at a sooner time on the x line, right, on the x-axis. This basically explains us that the rate of change has increased, right? And what happens when the rate of change decreases? The function tends to stretch. When the function stretches, we see that the reaching to the value of 1 on the y-axis basically becomes later in the x-axis. So that means that the rate of change is now slowed down, and reaching to the value 1 on the y-axis is later in the x-axis. You would ask, how would we know that if the rate of change is increasing or decreasing? Now, one of the ways of doing that is finding the slope of the function, and that's kind of very tedious. And obviously, we're not talking about calculations here. We do not want to calculate, but we are talking about intuitions here. How can we understand a function by looking at it? The rate of change basically increases when fx increases. So you have to see if the whole function is increasing or is it decreasing. And the rate of change decreases when the output or fx decreases. When fx of the function basically decreases or increases, that tells us if the rate of change of the function is increasing or decreasing. So let's try one of the examples here. Let's try fx equals 3x plus 2. Now in this function, we see that when we multiply this whole function with a number by 2, so we say 2fx, then our function would become 2 into 3x plus 2, and that would become 6x plus 6. And now let's multiply with the input of the function as well, 2, and that would basically become 3 into 2x plus 2, and that would be equal to 6x plus 2. And now we see that multiplying it with 2 basically increased the value of fx, and fx has increased, so rate of change has also increased, but this will basically shrink the function, right? And in this function, we also see that the output of the function will again increase. And why are we saying so? So if x would be equal to 1, fx would be equal to 3 into 1 plus 2, which would be equal to 5. And now 2fx equals to 6 into 1 plus 6, which is equal to 12. Or f2x, 6 into 1 plus 2, right? So this becomes 8. So it means that this function is growing much faster. Its rate of change is much faster than the original function, right? And this one is also faster than the original function we see here, right? So here also the rate of change has increased, and so the function would shrink. And that is obvious. But let's compare these two. Let's compare these two, multiplying the input and multiplying the output. In the last function where the fx was x squared, we saw that the shrink was greater for multiplying with the input. But do you think it would be the same case here? No, because right now when you multiply it with the output, the complete function gets multiplied, and this would give you a larger value of y as compared to this. As you can see here, it would give you a larger value of y. And so the conclusion sits still here that if fx increases, the rate of change also increases and the function would shrink. And the larger the increase in fx, the larger will be the rate of change and the larger would be the shrink. And if fx decreases, the rate of change also decreases and the function stretches. The greater the decrease in fx, the greater would be the rate of change decrease, and so the stretch would be bigger and the function would spread out more. I hope you understood how stretch and shrink works when it comes to function transformations. If you like the video, don't forget to press the thumbs up and subscribe to the channel for more such content, and thanks for watching.